So, in the continuing series of lecture on the reinforcement detailing that I am delivering, in this particular topic I am going to cover the detailing aspect or the requirements of the RC beam element in a structure. So, we will go to the next slide to see the various aspects, the lapping or the placement of the bars in a beam. So, in the first figure, if you can see that the bars are lapping at a particular location. Just come to the right side of the figure. You can see in the first figure what I mean to say is how the bars have been provided. We can see the bars are provided side by side. The new bar which is now getting lapped over this point have been provided side of the existing bar. This should be highly avoided. Here we can see the bars have been transitioned here by just giving a kink of slope not more than 1:10, and how bars are provided come to the section. Here we can see how the bars to be provided. So, this black dotted bar shows the existing and only the normal white dotted bar is showing the new bar, and you can see here the how the bars have been lapped. It is given above, it is taken above the existing bar. This practice has to be invariably followed and no bar binder knows about this. Now, another important aspect, that is lapping of the bars in the cantilever beams. So, cantilever beams in a structure is a crucial point. We have to give some special focus on this aspect. So, here you can see in the do not figure what I want to show. You can see on the right side how the lapping is given for the bar that is taken inside the cantilever portion. Here you can see the lapping has been given at the junction of the beam. This not only endangers this aspect, this also can lead to failure of the cantilever slab in a very premature manner. So, for the correct location I am showing the figures under the do head. Now, you can see the best possible way in this case would be that we continue a single bar from the left side beam to the right end of the cantilever. That should be the most ideal thing should be done on the ground, but at times it may not be possible depending on the length of the reinforcing bar where the lapping is mandatorily to be given. So, what we can do? We can see the bottom figure how the lap is given. The lap is never given at the junction or inside the cantilever beam. The integrity and the rigidity of the cantilever beam has to be maintained. So, accordingly we have to give the lap length inside the beam portion, and the lap length should be 1.2 times the LD or the design development length. If we are doing so, the bar binder, we have to tell the bar binder to follow this way to maintain the integrity of the cantilever slab or the beam. Now, coming to the positioning of the bars in the beam. Here you can see the figure on the do not what I want to mention. Now, you can see the bars are now provided in two layers, there is a top layer and a bottom layer. So, people or the bar binder while doing the bar binding, what they do, they just normally keep the one bar above that one without understanding what is the space requirement is there. The bar can be overlapping directly on each other, which is not the conducive condition for doing the detailing. Why I am telling this? When the bars are now lapping, suppose the top bars are now lapping immediately on the bottom bars. So, what will happen? We can see while designing, we take the effective there as the CG of the reinforcement case of the bottom. If we are doing that, now the effective there is now increasing. So, our design is now not getting followed in the side detailing. So, what we have to do? We have to ensure that the bars in layers are put by giving a proper spacer bar in between, so that the alignment, the spacing are maintained. Another aspect is also there. If we are not maintaining the space between the bars, the bonding of the bars is getting affected. For the bonding, the individual bars should be getting, the space is not affecting, the space is not available, and the concreting also cannot be done between the bars, which gives the bonding effect to the reinforcing bar. So, invariably we have to put the spacer bar as shown in this drawing while doing the detailing at the site. Now, coming to the unequal covers in the beams, most of the time we will find this is happening on the ground. Actually, what happens, the dimension of the beam or the columns, those are fixed in the layout, but while putting the reinforcement cage of the beam inside the column and other places, what the bar binder, they generally many times never follow the right alignment. So, what they do, now the formwork has been fixed. So, while fixing this alignment of the cage, what happens that you can see that the cover in one side has come down and cover on the other side has gone up. So, this is a case of the unequal covers. But as for the right requirement, what we should be doing, we have to ensure the right alignment of the beam is maintained, so that the cover on the left edge, on the right edge, on the bottom, on the top, everywhere it is maintained as per the design criteria. So, we need to check this aspect everywhere while checking the reinforcement detailing for the beam. Now, coming to the reinforcement detailing in the gables or the sloped beams. So, in the first case where I am showing the do not, you can see, and the do you can see. In the do not case, what is actually happening or the people do, they continue the bars or the bottom bars like this into the next portion, top bar like this into the next portion. This setup is also given as one of the option in SP 34, but it is never recommended to follow this kind of setup. This gives rise to the cracking at this opening junction, because SP 34 has been devised in 1987, it has not been revised, that is why this setup is already given, but in actuality in the practical aspect you should be avoiding this one. So, what best we should be doing? We should be doing like this, whatever the bar that is the tension reinforcement is coming, it should be taken off here and given LD here, and similarly this bar also taken to top and given LD here, and in the top we should be providing the additional reinforcement like this. So, this increases the integrity or the rigidity of this joint which avoid the cracking. I will be just showing another minute detailing in case of the large span beam. So, here it is a large span sloped beam, where the in between also one beam is running, that is the ridge beam. So, as I was mentioning how the reinforcement or the development length is given, we can see here. Now, this bottom bar is going here and given a development length. Similarly, this bar is also continue to the top and given a development length. On the top bar, whatever is coming, also we can do similar type of bend up. Now, this bar is taken over here, given a bend here. Similar, this is also taken, given a bend here. And in addition, what we can do, we can provide a 10 diameter rod or the bar across this. So, this provides more rigidity and sanctity to this junction. In all the cases, under whatsoever load is coming, the cracks in the central portion of the beam will be avoided if we go by this kind of detailing. Now, coming to the details of the beam intersection. So, here we see the different scenario. In the first scenario, there are two types of beams in a structure, that is the secondary beam and the main beam, and there are a lot of intersection of the secondary beam with the main beam. So, in the scenario number 1, here we can see the depth or the dimension of the secondary beam is less than the main beam. So, in this case, how you should be carrying out the reinforcement detailing at this junction? We have to ensure that whatever the main bars of the main beam are coming, they should be taken in single alignment, and whatever the bars of the secondary beam is coming to foul in the main beam, they should be given a smooth transition by giving a kick and should be taken inside the main beam. It should never be done otherwise, where the secondary reinforcements are taken and the main bars of the main beam are given a kink. That should be avoided at any cost in the ground. Now, coming to the different setup, that is the both main beam and secondary beam are of the same depth. In that case, as I was mentioning, we have to ensure that whatever secondary beam bars are coming, they should be given a bend and they should be taken inside the main beam. Similarly, the top bars as well as the bottom bar. Main bar of the main beam should be allowed to continue in the regular alignment as it is going. Another setup also we can follow, when the depth of the secondary beam, main beam are equal, we can do as shown in this figure. We can just give a bend or a kink to the bottom bar like this, take up to this one, this side bar taken up to this one. This is also meeting the joint requirement or the reinforcement detailing requirement of this junction. This setup is generally very few people know about this kind of setup, but it can be very well followed. Now, coming to the case where the secondary beam depth is more than the main beam. Here we can see now main beam is going and secondary beam depth is more. In that case as well, we have to ensure the secondary beam bar is bent or given a kink and taken inside the main beam. And the bottom portion, what additional safety measure we have to take, that we have to provide a horizontal bar and minimum length should be 450 mm minimum on the both sides. So, this kind of setup we need to follow, we have to ensure on the ground while doing the reinforcement detailing. With this, I conclude my lecture. Thank you.